Hey everybody, this is the examples for homework number 43. I'm going to work out the first example with you. The second example I'm going to work out but not talk through it. So you can pause the video and look at my work. And the third example I'm going to do the same thing, so the video won't be as long and take as long for you to look at. And then if you want help to know how I did the individual steps for example 2 and example 3, you can ask me in class. Okay? Okay, I am also going to write down steps as we go, like the steps we did in the steps video. Okay, first step, already in standard form. Step 2 was, are there any fractions? If there are, get rid of them. But there aren't, so no fractions. Step 3 is we need to multiply the equations by something in order to get one of the variables to cancel out. Now in this case we have two choices. We could multiply this top equation by a -4 in order to get the m's to cancel out. Our other choice is we could multiply the bottom equation by 2 to get the n's to cancel out. Your choice. When I do this in order to show my work, what I typically do is, and I'm going to have to rewrite the equations here because there's not room to do it, but when you do these problems on your paper, I want you, next to the original system, I want you to show what it is you're going to do. Okay, so I know that you multiplied the second equation by 2. Sorry. And then I'm going to say, and that gives me this system of equations. M minus 2n equals 16. And then the new equation, which will be 8m plus 2n equals 2. Don't forget to multiply the 1 by the variable as well. Okay? So that was step 3. Now we're going to add these equations. So we get 9m plus 0n equals 18. We divide both sides by 9. I'm ignoring the n because it's now 0. And we get m equals 2. Nice. So that was step 4 to solve for the variable. Now, step 5, we are going to substitute m equals 2 into one of the equations. We can use whichever equation we want. I'm going to use the second equation simply because I can see that it might be a little bit easier, but it really doesn't matter. So in place of the m, I'm going to write the thing I just found, which was 2. So now I have 8 plus n equals 1. And so if I subtract 8 from both sides, I get n equals -7. Okay? Now I've got my two variables. So step 7 is to write my solution as an ordered pair. The variables go in alphabetical order, mn. So 2, -7, remembering this is m and this is n. Okay, moving on down the page, I now go to my last step, which is to check. Important. And to do my check, remember, I plug into both equations, m minus 2n, equals 16 is the first one, and 4m plus n equals 1 is the second one. And remember, my solution I'm testing is 2, -7, in which 2 is the m and n is the -7. Okay, so m, which is 2, minus 2 times the n, which is negative 7. I think I should have picked different variables. I get 2 minus negative 14 equals 16. That's 2 plus 14, which is indeed equal to 16, so that one checks. This one over here, I get 4. Remember, whenever you substitute in, put parentheses, it will help when there are negatives. Okay, so into this spot goes my m, which is 2. Into this spot goes my n, which is negative 7. So I've got 8 plus negative 7 equals 1. And 8 plus negative 7 is indeed 1. So I'm good. And I'm finished with this problem. The solution to the system is 2, negative 7. Okay? Okay, so for this problem, as I said, I'm going to do the problem out and then show it to you without talking it through all the way. And then you can check it. If you have questions, ask me in class. I do want to note one thing before I start this problem. This is not in standard form. So my very first step is going to be to rewrite this set of equations in standard form. Now don't forget, when you rewrite something in standard form, you have to add and subtract the variables and numbers from each side so that you can move the variables and numbers around. Don't just pick them up and plop them onto the other side. So as the step here where we need to decide step 3 about what we're going to multiply or divide by, I have two choices here. I could multiply the bottom equation by negative 3, which would allow the x's to cancel out, because this would be negative 9 right here. Or I can multiply the bottom equation by negative 2, which would make the y's cancel out. Whatever you want is fine. I'm going to do this problem by multiplying I'm going to multiply the second equation by negative 3. Okay, so here's the problem worked out. You can pause it, look at my work. The solution I got was negative 3, negative 15. Make sure that you're showing your work. Even if it doesn't look exactly like mine, you need to show your work. Okay, and now we'll do the check for this. Remember, when you do the check, to make sure that you substitute into the original equations. Okay, so here's the check. It worked, and we're finished with this one. So now we'll go on to the last problem. Okay, in this equation, in this system I mean, as it says, we can't just multiply one equation by an integer. We have to multiply both equations. So we have two choices. We can eliminate the x's by multiplying the top equation by a negative 2, for example, and the bottom equation by 5. Or we could eliminate the y's by multiplying the top one by 8 and the bottom one by 7. It doesn't matter, you can do whichever. An advantage to eliminating the y's would be you wouldn't have to multiply either equation by a negative, because these signs are already different. An advantage of doing the x's is the numbers are smaller. So I am going to multiply by negative 2 in the numerator, in the top equation, by 5 in the bottom equation. Okay, so here's the solving of the equation. I got y equals 3 and x equals 1. And now I will go on to checking my solution. Okay, so I see here that in the video I don't have another slide to do the check, but I did check it and it does work, and you have space to do it on your handout, so go ahead and check it. That's it.